Hello everyone and welcome to another episode of Solving Advent of Code in Rust and try to learn Rust in between. I'm Roberto and we have...
Luciano, hello.
Thank you everyone for following along. If you never did Advent of Code is a code challenge that is published around every year around the Christmas period. We are working toward the last year one. There are 24 challenges and you can find them on adventofcode.com. We are publishing all our code on a GitHub repository and we have a YouTube channel where we publish all the recording. You can find the link in the description of the Twitch channel. Last time we were doing exercise 23 of year 2021. It was about small animals that have to go in their hole and moving around and exchanging and mixing together and all of that kind of stuff. And we did some of the code that we need. We made a class for struct, for the board, for the playfield, for whatever they live in. And we made a function to get all the possible moves that all of them can do. And now we have to implement today the function that apply the moves to a state and give us another state, and the true solution, the main cycle that use those functions to get the solution of this Advent of Code. Right, Luciano?
Yes, sounds good. So I'm gonna maybe share the screen and we can quickly review what we did. So just to recap on the problem, this is our input. And this input basically, let me make this bigger, represents like a cave with these animals called amphipods. And there are two parts. The first part is this hallway, and then there are caves here, like this, where you see letters A, D, C, D, B, B, A, C. So there is an horizontal hallway and vertical caves. And the goal is to have all the animals ordered correctly in their own caves, which means the first vertical cave should have the animals called AA, then BB, then CC, and then DD. And they can move around to try to sort themselves. And this is basically what we need to do. We need to figure out exactly how to shuffle them around so that we can sort them back, everyone in their own cave. So we need to simulate like potential moves and try to figure out which sequence of moves will produce the sorted caves. Now
every step of those animal costs. So A is the cheapest one, B, C, and D are the more expensive one in order. And so you have to find a solution that is the less expensive one.
Exactly. And for instance, when they move, they cannot jump above each other. So for instance, if you take A and move it here, then you cannot take D and move it to the left of A. So you need to always, it's like they're blocking the hallway effectively when they're positioned.
D can't go out, and D can't go out before A is out of the way.
Exactly. So we need to simulate this kind of two-dimensional space and all the movements that they can do, calculate all the possible outcomes, and then every time we find an outcome that is actually sorted, we need to see the total cost of getting from the initial input to that outcome. And at the end of the day, what we want to find is whatever is the cheapest cost to get to a sorted outcome. Now, last time we had everything in one file, and we took the liberty of splitting it into multiple files just for simplicity. So let me make this a little bit smaller. So the first thing that we have is this amphipod. I cannot pronounce it.
Amplifon, yeah.
Amplifon, yes, which is going to be fun only for Italians. So this is basically an enum because we can only have 4 different types of them, and we don't really need to know anything else. Then we implement a few functions. For instance, we implement move cost just to keep track of the cost of moving of one cell every different type of animal, whatever.
Yeah.
And then we have this desired OM IDX, which is basically telling us A needs to go to the cave number 0, B needs to go to the cave number 1, and so on. And finally, we have a from char just for easily creating an instance of this particular type based on the character that we find on the input. Then we have this burrow struct, which is basically representing the entire state, if you want, because there is an hallway, and then there are holes or caves or whatever you want to call them.
Yeah.
And hallway is effectively these 11 positions that we saw in the input that determine the hallway. And they are optional because you don't necessarily have an amphipod in every single cell. So only when you have one, this will be some amphipod, otherwise will be none. The holes, there are only 4 of them, and every hole has, in the input that we saw, there are only 2 positions. But then in reality, in part 2, we can have 4 of them. So here we are keeping things simple and just having a vector. We can see later if it's worth optimizing this. And finally, because a burrow is kind of a state, what we want to do is basically create an initial state, then keep cloning it and change it as we go through the different movements and the different configuration. We keep the cost inside the struct so that we can easily consider that as like a standalone state that we can take, branch it out, and try different permutations. So then here we implemented a bunch of helpers like this between, which allow us to see basically, it's a way to slice the hallway into and figure out if you can go left or right. And then a bunch of moves that basically tells us, given a configuration, the current configuration, what other moves can be done from that particular configuration. So this returns a vector of commands. And let's quickly look at commands. We are basically doing this thing where we use the command pattern to describe every single movement that an amphipod can do. And the movements are either from inside a cave going outside in the hallway, or vice versa, from the hallway going back inside a cave. So this is where we have two variations. And for every variation, we have a position in the hallway and a position in the cave or home or whatever we are calling it. And that's pretty much it. And we spent a lot of time in the last stream to kind of build this function. Now what we can do, what do we have here? Oh, this is just the parsing logic. Now what we can do is we could take this sequence.
And last time we wrote also a debug, a print, a test to see all the possible moves from the starting state.
Mm-hmm. Yeah. So, that's still here. No, where did we move it? Did we move it here?
We lost it. Cool. No problem.
I was quite sure. Oh no, we just did it in part one as a DBG. We didn't write a proper test because
we can implement the moves now to take all the moves that come out of this. We take the first one because obviously they are 27. It's not that you can test all of them, and we can apply it. Then we can see the output of the state.
Yes. So this is what we did here, right? But we need to apply now.
Yeah.
So here we show all the moves. So we need to write the apply function, right?
Yes.
Do we want to write it here as another function?
Is a functions there that is taking self and is giving back a new self.
It's taking self
and
a command. It needs to take a command, right?
Yeah.
Let's call it CMD command, which can also be a reference. And then it returns a new self. And it will be a new instance.
A new instance, so we don't have any problem, I think, with borrowing because we are creating it. Oh my god.
Oh, look at that. I'm almost curious to see how much of this is correct.
I mean, the clone is fine. Yeah. The match, we can try to accept everything, then we review.
We probably want to clone the entire self.
Yeah, we want to clone the entire self.
Not them individually.
We are cloning them individually. There is not a big reason to clone them individually. I mean, it's easier to touch them, to modify them if we clone them individually, probably.
I think. We'll just do this, and then at the end we return new state.
Okay, let's see what's going on. How is taking it.
And then we need to do, we probably need to do a match on CMD.
Yeah, my only concern here is that we have in the holes vectors, and I hope we are cloning the vectors, not cloning references to the vectors.
That's a good question.
I mean, in Python, when you assign a list variable to another variable, you are not creating a copy, you are just assigning the reference. So both variables will point to the same list, the same vector, and you will come out with the funny bugs, I will say, from that, because the code will point always to the same vector and everybody will share the same vector.
We can test it, I guess.
Okay, let's try without thinking too much about it, and then we.
I mean, the easiest thing we can do here is, for instance, here, right? What we can do is literally, let me comment all of this, because whenever we can say let b equal vec 1, 2, 3. And we do let c equal b dot clone.
Yeah, but we have an array of vectors. So is this different with an array of vectors?
Well, we can do vec.
We have an array, not a vec of vec.
I don't think Do we have an array?
Yeah, we have an array of
vectors. Yeah, we can just do this, right? This is just an array.
It's an array with one element. I'm fine with that.
Okay, now what we want to do is set 0, 0 equal, I don't know, 4.
Yeah.
And then I want to dbg b
And C.
dbg c. And if we see the same value, then we have a problem.
Yes.
It's compiling because I just updated Rust. Why is it complaining for things that are not related?
Yeah, no, that is the apply.
Oh, yeah,
We
okay.
stop it in the middle. Comment it for now.
Let's just do. We cannot even clone, whatever. Okay, cool. No, it's this is the first one. It keeps one,
yeah.
and so it does work as we want.
Perfect. We can clone.
Yeah. Okay, so we can clone. So if we go back to here, we can clone this, which didn't like it. Why?
Because not everything is clonable.
Okay, wait. I'm not too sure why it's saying double reference. So what's the solution? Is there a quick solution? Try the referencing. Okay, can we just do this? But when you dereference, you do take ownership?
We lack the trait to clone.
Yes, that's maybe why. Is that going to be enough? Because Amphipod is clonable, right? It is. So that should be okay at this point. Okay.
Yeah, I'm just worried that we can apply only once and not twice.
Because we are the referencing, right?
Yeah.
I'm not too sure either. I guess we will see and we'll figure out.
Okay, let's go on.
So here we return new state. Now we have it and it's
yes.
a new self. Now we match on the command. And what do we have?
We have to command out and command in.
Yeah, so let's accept this and see what we have to do. So when command is out, what do we need to do?
When command is out, we have to take the amphipod out of his hole. The first amphipod of the hallway. So what he's doing there is taking amphipod, the new state hallway of the position in the hallway. Waypoint. Why the reference there? Because it's a use okay.
A reference, yeah.
But why always
no, that doesn't make sense, right?
That is the wool array. That is the wool array.
And why is inferring it as an amphipod? That's the thing.
It's not an amphipod in theory.
Exactly.
In theory, is always is an array of vectors of amphipod, right?
No, sorry. This is the hallway, yeah, not the holes.
Yeah. Okay, so we don't have to. This is the command to go out. We have to write in that place, not to.
Yeah, exactly. I think it's swapping the meaning. Close enough Copilot, but no.
Yeah, I think he's a little bit out of. Yeah. Okay.
Let's do it ourselves.
Well, try to keep that code as reference, but let me see what is the, part 2. Part 2. Sorry, I mean the command in reality is out because the part below is taking the amphipod out of his hole. Also, the math around the pointer is correct. The pop is only that we have to pop from the front of the vector. I mean, it's not super important to choose, but in theory, yeah, we have to pop in front, and instead he's popping from the bottom there. And okay, line 112 and 113 are fine, but for the out command.
Yeah, exactly. So we can swap.
Yeah.
For now.
Okay, let's review the in at this point. Let's start from the in. The in we must take the amphipod from the hallway.
From the hallway, that's correct.
And there must be one, otherwise we don't have this command here, in theory. Then we are setting the hallway to known, correct. And we are putting we have to push in the front.
Okay, so to do push front, do we need a vector queue? I'm not too sure if there is any other easy way.
There is not an insert on position 0 in a vector in Rust.
Let's see what it does. I don't know if it's going to shift all the others. Well, does it need to shift?
Yes, it needs to shift, but it's an insert with the shift.
Let's see. Insert an element and position index within the vector shifting.
Yeah, you have
okay.
to push the position 0. It is the first. We can try to optimize and making the logic the other way around. But for now, let's start like is implemented in the Python version that we already have. And then we go down the whole of optimization. Here, we also need to update the state, something that Copilot didn't suggest that you.
Right.
Oh, the cost is already in the state, in theory.
No, sorry, the difference.
What do you mean by difference?
We need to add something to the cost, right? When we perform this
movement. But we can compute that from the numbers that we have inside the command match.
Do we know based on
positions? Yes.
Because
well, let's keep that variable here and we will populate it there. Okay. 107.
Okay.
After line 107, we have to compute this cost at this point.
Yes, exactly.
The cost here is the cost of the amphipod, that is exactly that code, multiplied by, now open a, is not that.
No,
that is only a part, so open a round bracket. It is 1 plus the depth of the hole. No, sorry, the depth of the hole, that is 2 for part 1. Do we have that number somewhere? Because for part 2, it will be 4. Let's do part 1. Put a 2.
Okay.
But this is the depth of the hole. So if you want to leave a comment for later, this must be 4 in part 2, and it's 2 in part 1.
Let's do this for now.
We can add it to the state. Yeah, but we have to reason.
I think we can do like a const generic later. Well, let's see.
Yes, it's right. It was one of the suggestions.
What it was here.
Yeah. And you have to subtract.
We have to subtract.
Okay, here we are in which case? Here we are adding to, we are moving inside the hallway.
No, here we are in, so we are going from the hallway into the cave, right?
Okay, so from the hallway into the cave, sorry, okay, so there is not that one. So sorry, it was wrong.
This one
just
is not
the
that.
depth, yeah. This is depth, and you have to remove the size of the array new state holes amphipod desired DOM index. Yeah, exactly what is writing Copilot. Plus, inside the round bracket, plus the ABS, absolute.
Oh, yeah. Okay, absolute. We need to say that at the end. I think it's dot ABS in.
Okay, so okay, at this point, I open a round bracket to surround it with the dot ABS. Okay, and this one is the position in X, that is home X, minus the position in the hallway. That was what is the variable?
Position hallway.
Position hallway. Post hallway. Yeah. So basically, this means the side on the with the ABS on the right is the horizontal movement. So from the position in the hallway to the position of the hole. And I want it absolute because if I come from left or from right, doesn't matter. It is a positive number of steps always. Yeah, okay, casting with.
I don't know if there is an easier way to do this. Why doesn't like it?
Because it's a reference. So you have to, as a reference to. Oh, okay, or just to do that. It's an integer, who cares? Now is.
Is there a better way? Quick fix?
Unsigned absolute. Oh, nice. Yeah, but the brackets just disappeared.
Yes, I don't think that's what we want. Right?
Yeah, I like the unsigned ABS, but I want to keep that side. Cool. So the line 112 is the horizontal displacement. So how much we have to move horizontally. The line 111 is the vertical movement. So if we have a depth of 2 and we landed in no, the one below is the horizontal. The one above is the vertical. Is the
yeah, right. It didn't like my comment. Okay.
So I was saying, when you go inside, there is the you have to pay the going inside and then the horizontal movement. And the going inside depends on the depth of the hole, because if the hole is, if we have 4 stuff to fill and you go in and you are the only one, it means that now the length of the array after we insert you there is 1, but you have to do 3 steps to go to your position.
I'm trying to see if there is an example, like for instance here, right? If B needs to go here for whatever reason, we need to calculate this horizontal cost and then the vertical cost of this additional
and then the vertical cost, that is 2 minus 1. Now I don't get just I have just do you know what? We have to compute the cost before putting the amphipod in.
Yeah, because we need to know exactly.
Yeah, we need to know before putting the amphipod in. Then we have to put the amphipod in. So you just have to move the insert after the cost calculation.
The insert is this one.
Yeah, after the cost calculation. Otherwise, we are off by 1, obviously.
Okay.
This
and
way
now
we went
here we need to do new state dot cost equal
so plus equal. Can you do plus equal?
Yes.
Cost. Okay, coming out from the hole is, let's see what it wrote. He wrote the new state. We have to pop from the front. So can you pop a specific index like 0? Pop left? I don't
know. Good question. I think with the vec the queue you could do it with this. I don't know. Let's try.
I think you can also with this. It's just less performant. Why you should
is there like a shift maybe? No. Let's see what you have. Here clone. If anyone knows in the chat, let us know. And fill first. But first doesn't pop. It's just reading
first
it, right?
Doesn't pop. Yeah, there is a self remove. There is a remove, but I think remove is not giving you back the.
No, it does. It gives you back a T.
Okay. So is remove 0.
No, but remove once a ref. Okay, once the USide, so once the index, yeah. So 0, yeah.
Okay, it's giving you back an amphipod, if any, because it can be that it is empty. Why is complaining?
Why doesn't give you a sum? That's interesting.
Remove the element position within the vector, shifting all the elements to the left. Cool, is what we want. And it's giving not back an option, it's just giving back.
Yeah, that's why I'm surprised.
If you want to remove from beginning of that, consider using vec the cube up front. Yes, we know. Late optimizations. Well, I'm fine using remove with. I hope just that it's stable or not a nightly build.
Panics if the index is out of bounds. Well, it's weird because I didn't expect that, but good to know.
I was expecting an unwrap too, but okay. We can live. I can live with that. And then they always get populated. With
is this correct, by the way?
Yeah, because that is the x of the hole, and in the command we have the x of the hole. That is 2, 4, 6.
Oh, right.
And to go to the array index, 2 must be a 0, 4 must be a 1. So you have to go left by 1 and divide by 2. Because otherwise it could be also, because 2 becomes 0, 4 becomes 1. So it's divided by 2 less 1. Otherwise we have 1, 2, 3, and 4, but array start at 0.
Right. Okay, then we do this, which is basically in the hallway, in the position of the hallway.
Put that in the.
Yeah, so also here now we need to calculate the cost, right?
Yeah, now we have to compute our cost.
Here doesn't matter, we can do it at the end, right? Or not?
Let's see. So now we are going outside, right? We are in the outside, yes. So going outside, it means that our cost is again the horizontal displacement as absolute, like before. So you can copy line 113, it's the same. Okay, you already copied it.
It's Copilot is doing everything.
Perfect. Instead, for the vertical displacement is 1 plus the depth minus the len of the, there is a 1 plus in front of depth. Let's see if this makes sense. So if we are the amphipod at the beginning of the, no, okay, you can remove the 1 because we are acting after. If we are the amphipod at the top of the, no, we still need the 1. Sorry, I was saying If we are the first amphipod to go out,
let's see if there is an example.
We go out, so we have to pay the step to go out. The length of our hole will be, there is an example for sure somewhere, but we have to go in the hallway. That is costing 1, and that is the vertical movement. Then we have to go.
So let's say the same example that this B was here and just moved out, right?
Mm-hmm.
So you still need to pay 1 because you're going up.
Yeah.
And then it
is the absolute of the difference between the coordinates. I was thinking of that one because if we do that after having removed the amphipod, so the length will be 1, and we do depth minus the length. I think the +1, the 1 plus is not needed. So they are exactly the same in the end. The two costs are exactly the same.
Yeah, but we are calculating 1 in between and 1.
Yeah, 1 between after. And 1 after. So yeah, okay. It was 1 plus if you were computing it before taking out the amphipod, but we're computing after, so you can remove the 1 plus. Makes sense. Because if the depth is 2, at that point the array will be 1 because we already removed the first amphipod, so it will be length 1, and the second amphipod will find a array of length 0, so it's 2 minus 0, but the second amphipod need to do 2 steps to go in the hallway, then moving horizontally.
Yeah.
So in theory, if there is no problem running this 2 times, it should work. We can try that in part 1, writing hard coding the moves. I mean, we start with the borrow as our input, and you can keep the debug of borrow. So we see that. Then we can do borrow.apply.
We create a new command.
A command out.
Oh yeah, we need to import. Use.
A command to go out.
Okay, and what do we want?
From position on position 2 to hallway position 1.
And why is not happy? Oh, because it needs to have a reference, yeah.
Okay. Now copy and paste. We do another command to take 2 out and go in. Yeah. Now we do new borrow, apply. Yeah, we can debug it to see that the amphipod went out for it. Now we
do we do the inverse, right?
No, we move the other one also out. So the second one out in position 3, and then we put back the first one in the hole. So we test that 2 out and 1 in. Why is it in now? That's out. Copilot, what are you doing?
So it's the exact same thing, right? You want
no, it's going in position hallway 3.
Oh yeah, one is going left, one is going right. Okay.
Yeah. And now debug this new borrow. Well, probably you have to change the name. I don't know.
No, you can shadow, unless you want to keep them for whatever reason.
No, we can shadow. There's no problem. Now we try an in, and we take the one that is in position 1, and we put it in the position 2. Now this is an in from hallway position 2. Hallway position 1 to home position 2.
Okay.
Yeah. And we debug again a new borrow to see what is there. Let's see what we have.
Now this is going to be fun to
We only care about the first hole. Okay, there was an A and a D, right, to start with. Then we moved the A in the hallway, in theory.
In position 2, right?
1.
So this one.
1.
So we'll be here. Okay, some A.
And we have some A.
And this one has only 1
there is no more A. Yeah. Now we move D out of A, and the cost is 2 because moving this costed 2.
Yes. Now moving D.
Now we move D out.
And it's going into 0, 1, 2, 3. Now this first hole is empty,
and now
the cost is 1002 because
now it's too low.
Yeah, there is something weird there.
This is too low.
It's like it did only 1 movement.
The first one is fine because it's doing like this and this is 2. But this one needs to be paid 1000 for each step, and it has to do 1, 2, 3 steps, not 1. So we have to review our cost code.
Yep.
It's good to have this kind of tests. And then look at if at least it was fine going in.
Let me see. Sorry, I closed it. I need to run it again. There. So going in. So this is the last one, right? So we have D.
There is no more A.
A went there. And the cost is added by 3. Is that correct?
Yeah, because it is.
Oh, because it went to the bottom. Yeah.
Down. So went to the bottom, obviously, now, because should to go out, but free to go in. So on A, we are computing right. D, no. Let's take a look at what's happening at this point. Is the out that has a bug in the cost.
Okay, let me quickly copy
but
this.
Why only for A?
Let me quickly do this, and we can do a test here.
CSG
test or tests? I can never remember. Test and then mod tests. Use super blah blah blah. And now test moves.
This is test apply.
Oh, now okay. The input is, let's take the input from here.
Here, technically, you are testing the apply function, not the moves function.
Right.
But if you, I'm picky, sorry.
Okay, so what we want to do is basically to say, why it doesn't format it correctly?
Are you missing some closed?
Yeah, also it's not showing me the tests, so there is something wrong there. I don't know.
Do you have enough closed curly brackets? The mod test brackets is closing somewhere?
Yeah. And test apply there as well. Okay, whatever, doesn't matter. I'm only surprised that it doesn't give me the play button to run the tests. Like here we get
that. Do we have some syntax error? No, I don't see any. Have you marked as test the function?
That's why. Now it makes sense. Still not formatting as I wanted, but whatever. Doesn't matter that much. Okay, so the first thing that we want to know is, for instance, we can say assert burro.cost is 0.
Equals 0.
And we do the new one, and we assert at this point that the cost needs to be 2, right?
2. Yeah, because up and left, 2. And it's an A, so it's cheap.
Okay, then we have here D that moved 2 up, right? And 1 left,
and
1 right. So the cost should be plus 3,000. So we are 3,002.
Yeah. Then we put back in A, and it's costing 3 to do that.
So we put back in. So A moved
1 left, 1 right, sorry, and
1
2
right
down.
And 2 down. So it's plus 3. So we end up with 3,005. Okay,
and now those are fading. These one are fading. No, you have to assert on top of new borrow, not on top of borrow.
Good point.
Except the first one.
Yeah.
Yeah, the first one is borrow, but all the other one are new borrow.
And now it should fail on this one. Expected 3,002 and found 1,002.
Yeah. Okay, let's go to see what we did in the move out when we do the command out in that match.
Yeah.
Okay, the move out. The move out is the depth minus the length of the hole. So
here the length will
on the bottom.
Will be 1, right?
Will be 0 here after we move out D. Because we move D out of new states holes. Fuck, we didn't do the math there. We have to slice by 2 minus 1 also in this index.
We have to slice by 2. This index here?
That index there is 0, 1 based. I don't remember. How is that based? Is it 0, 1, 2, 3 or is it 2, 4, 6, 8?
Let's see. Yeah. 0, 1, 2, 3.
Okay, go back there, then I'm wrong. This is the desired home index. Okay. Desired home. But it's not the desired home index, it's the home x is our variable that we have to use. Copy star home x.
Yes.
This is Copilot fault.
Yes, and we
Star
trusted it so
Omex
much.
sliced you. I trusted it too much. You see why I say that Copilot is dangerous.
Yeah, I agree.
Same on line 114 at this point.
114. Is it? Yes, because we need to respect the command, not necessarily what they want to do. Right?
Yeah.
But also
And
here,
also
or not?
line 111. Yeah. We were just lucky that we worked with A against the first hole. So it was always fine because A was to go in the first hole. So it was like a coincidence.
Okay, so now should we run the test again?
Yeah. Let's see if now we are.
Yeah, now it's okay.
I don't care. I don't care where they want to go. I care what the command tell me that they need to go. Then the command will contain where they want to go because moves is creating the command in the right way. Sorry, I missed it if it was okay.
It was okay.
Okay. Now, in theory, we can make more of those, but let's see that this test is enough for now. Now we can go implement the solution.
So here, let's clean up everything.
Yeah, because we moved to the test, all of this.
Okay, so we create a new borrow from the input.
And we have it. We create our solution that is a minimum, so is a let mutable
in cost.
Something. Min cost as a usize maxint. But we can start with maxint. Yeah, we start with as much as possible. Now we create a stack, so we create a vector of borrow.
What do we call it? Next
our
moves?
Stack, those are all the possible states that have to elaborate.
Let's call it states.
Yeah, states. That is a vector with only borrow inside.
Yeah.
It's not a vector 32, by the way. Okay. Why Copilot A32? Makes no sense. And we need to keep...
just guessing.
And here we need to keep, and I don't know if Rust can do this, an hash map of the scene states and their cost.
All right, I remember that. Moot, yes.
Is a map
hash. So let's call it scene states.
Yes, scene states. That is the key is the state, so the borrow. And now we
will probably need to make it hashable, but it should be easy.
And the value is the usize, is the mean for that state, because there are two scenarios. You go in a state that you already passed by with, and you pass it by with a lower cost, so it's useless to go on this route. You pass by a state that you already saw, but now you have a lower cost, so you have to overwrite that in the hash map and go on in this way because it's still meaningful to proceed. Now, Burrow is not hashable at the moment, probably, so.
I don't know why it's not complaining. I'm surprised. Did we make it hashable already? Or...
Let's wait for the first time that we try to access it, then we see if it's hashable.
That's true. Maybe we see it later when we start to insert stuff. Okay.
Now, while while state is not empty.
State. Well, let's do while. How was it? Yeah, exactly that. Thank you, Copilot.
Yes, because the first stuff we have to do is popping from. If it's solved, so if it's solved, it makes sense. Yeah, I think that one makes sense. Even the continue makes sense. If the cost is less than mean cost, continue. Okay. So this is keeping track of our local minimum.
So if it's not completed, then we want to see if there are more moves, right? So we get all the moves.
Now, yes, exactly. State, get me all the moves. We have a new state. Well, we don't need to clone in line 26 because apply is already giving us a new state.
Yes.
So the new state is our state dot apply move. Probably wrote like this, and now we'll see the problem about that star clone that we did in the apply command. No?
Not too sure.
And also we don't have to
we don't need to do this because this is
it's already done internally, yes. So we just have to apply the move. Let's not do this check here because oh no, well, yes, leave it there. Okay. If the cost of this state is more than our current minimum, we will not add this to the stack, to the states, because this is a losing state. Cool. Okay.
And also,
now,
if we have seen this already,
if we have seen this already and the cost was higher, continue. And the cost of the new state is higher, continue, right?
That's right. Okay. And then we insert it in the scene states.
Why clone it? We don't need to clone it. Why is cloning?
Yeah, should we do a reference?
Okay, let's do a reference.
I'm not too sure.
And we insert a reference to the cost. But the cost is an integer. Do we have use size? Do we have to put a reference to the use size too?
No, because that's the same cost, cloning it or putting a reference. So we can.
And then we add the state, the new state to our state. Yes, it's correct.
There is an extra curly brace.
Yeah, I think so.
Okay, now we see the issues. Okay, state is solved. We don't have any state is solved.
We wrote something, I think, or not. Go to see. We didn't wrote his final is.
I remember with that moves. Maybe we didn't create it. Apply. No, we don't have it.
Okay, probably we are confusing with the Python one that has it. Yeah, but we need a function that tells us if the borrow is final.
Yeah, so we discussed it last time.
Yeah,
so
we just forgot to implement.
Create fn is final.
And his final basically is okay. What he wrote? All the holes must be filled with the desired amphipods.
Ooh. The problem is that here we need to know the length, right? Because if they are all, yeah.
We have the depth as constant. That constant will become, like you said, something else. So, yes, all the array must be of length depth,
so this,
and all the array must contain the right amphipod for that all.
What was depth?
And the all must contain, all the element of the all must be the right amphipod.
What the hell is doing here? All 0.
No, go with. Do you have the index of the all?
Do I have the index of the all? I can get it with an enumerate, right?
And then we have a reverse map between the all and the amphipod that we don't have right now. We do with a 4. It's less. Do a cycle on top of
the it's easier to reason about it.
Yeah, so, 4 amphipod in ABCD.
In self dot. No, wait. We want to check only the alls, right?
Yeah, but you do that with. Cycling on top of amphipods. No, do amphipod in, and then you do an hard-coded array of A, B, C, and D, the enumerations. There is a way of having all the elements of an enumeration.
Oh, I see what you mean. Not that I'm aware. We could do it.
Square bracket A, B, C, D.
We could implement it in here. Pub 8 fn all.
Yeah,
and this returns
an array of 4 amphipod. Yeah, a vector, an array. I don't know what you prefer. Yeah.
Look at that, beautiful. Sometimes it's amazing what Copilot does. So amphipod all. Why didn't like it?
Semicolon instead of dot. And amphipod with capital A.
I think it's the capital A that is missing. All. Yeah.
Yeah. If they must be the whole that is a self-all amphipod desired by index must be of length depth, and it must contains all amphipod.
Okay, so if not self dot alls
of
amphipod desired on dot len. Actually, let me do one thing. let all equal that, and then if clean up everything, if all dot len different than depth
is
return false.
Yeah.
And then if all dot all an amphipod is different
from amphipod, then it's false. If even one amphipod in the whole is not in the first hole, if even one amphipod is not an A, it's false.
So should we just say any? Is them or some? If one is different,
yeah, return false.
But this return false. Okay, yeah, that makes sense.
If they are all of the right type, it's not returning because they will be all of the right type.
Mm-hmm.
It's not some.
What is it? Any? Oh, do we need either?
Try any on the iter.
Any.
And that is a reference, so you have to put a reference on the amphipod on the right. No.
Maybe it's the same. Yeah, works either way. I'm not too sure which one is best.
If the amphipod, if we find one amphipod that is not the right amphipod, it's false.
Mm-hmm.
Okay. Now we have is final.
So now we have is final.
And now it's complaining about cost. Why is complaining about cost?
Cost is private. Okay, that's my bad. So we need to make sure that all these things are public.
Well, cost is needed the public. The other one.
Actually, all the other ones are not needed. Yeah, you're right.
Okay, aside that you can do a getter, but I don't want to go in that path. Now
okay,
the apply
command
is
just apply.
Okay.
It was easy. Now, what's the problem with get? Exists for struct, but the straight bounds were not satisfied. Yeah, okay, well, now we need to implement hash. This is actually
now
really,
now it starts to make
really
sense.
weird. That
borrow must be hashable and EQ because probably he has to assert that.
Probably needs partial EQ as well. Okay, now the amphipod needs to be hashable as well.
His enumeration is easy.
Cool. Okay, back to library.
We satisfied everything.
New state doesn't need to be immutable because we're not changing it anymore in here, right?
No. Now it's complaining line 38. Why?
Does not live long enough.
Perfect.
Now we need a clone, I think.
Why is not living enough? Where is getting?
Because at the end of this for loop is going to be dropped.
No, it's going to be inside state.
Okay, you know what? We can remove the reference, and we can give it ownership.
But to state or to the vector? No, that is a. No, you have to put that in the hash map and in the stack. So it must go in two places.
You're right. I'm trying to figure out.
And going in the stack can go in the stack materialized. So can go the instance, not the reference to the instance. In the hash, I'm fine with just. But well, then it could be that it's disappearing from.
Exactly. Yeah.
We have to always keep it. Or we clone, and this is the easy solution. We
clone seems like the easy solution. Yeah.
Yeah. Okay. Let's clone to see if the answer is correct. Then we can try to optimize. So in line 38, we'll go with a new state clone. Yeah, one of the two, I mean. Now, so it's complaining for what?
No, here is complaining because as soon as you insert it, you are moving it, so you cannot read the cost there. So you should do let scene cost. What? No, stop.
No, less.
So we need to do this, and then scene cost. I think now it's going to be happy.
But scene cost is not a variable from above.
And new state we cannot. Okay. Let's push.
We cannot clone
before.
Okay, because we have to do that before. Okay,
we have it. Should we test it?
Part one, let's test it. Then we have to make the depth a variable or okay.
How confident are you that part one is going to work?
Not a lot.
Okay, I play at 50%. Okay, it didn't even run, so that's good. Cannot move. So, okay, this is here, which is behind the share reference. What are we doing wrong there? In line 137. 130. Why is complaining only now? There. Oh, in its final. So we did not realize that. We want a reference to all
The
of
reference
this.
is fine. We don't want to get anything in our end.
Right, so that should be enough.
Yeah.
Okay, let's rerun. Running. Endless loop. Or maybe not.
In Python, this takes 7 seconds if everything is working correctly. Why mute? Why cost is never used?
It did finish correctly in 22 seconds.
Run it in release mode.
Now, why cost? Where was that, by the way?
And look at the line he's telling you in the terminal. Yeah, I saw it.
Also here, why is importing self? That doesn't make any sense. Okay, here what? Unneeded return statement. Yeah, quick fix. Okay. What was the issue with the mute?
Let mute cost.
Was it here?
Where was it? I saw
Use
it
command, we don't need it anymore.
I saw it passing by, but
probably here is where we have some stuff left. No?
Try to search in the file, let mute cost, and see what you find.
Let's rerun. It's 101 of
101. Well, are we not using the variable?
Equal?
It must.
Oh, it's because we assign it only once?
So you can declare it not mutable?
I did not realize that.
But you are setting equal to 0. Then how can you assign?
So you can just do this.
As you size, can you do that?
Because it's kind of deterministic. There's going to be in one or the other, I guess.
Yeah.
And you are always assigning it. So that's probably why I was complaining.
Okay, let's try again.
It is slow, but this is in debug mode.
Still, yeah, try to run that in. This is without the queue, without optimization of any kind, and in debug mode. If you, from the console, try to run it in release mode, it's going to be fast. Still, 22 seconds is a reasonable amount of time. Cool. Yep. So, first optimization, we can use the queue instead of a vector for the holes. Second, are we popping from the right of the stack? Yes. It pop on the stack, on the states vector.
Mm-hmm.
But even there, we can try to use the queue, that is more efficient anyway. And there we could try to use the priority queue.
So here you would like to use a vector queue, right?
Yeah, now we have to change the insert and the pop that we do in the apply, because they changed the name.
So when we create the struct, we need to...
In the parser.
Where is it? Oh, sorry, from str there. How is this not complaining?
No, it's complaining 173.
Oh, okay, of course.
Line 173 is complaining, don't worry. Yeah, we need to find...
Okay, now push right. Correct?
Push on the right is push, or is called differently?
I think it's push
back,
front or back?
Back. Okay. Can we do something for the depth? Can you make me happy?
Mm-hmm.
Can you add to the struct for the borrow depth as a use size?
Or do you want to do it with a const generic? Because that's actually going to help us a lot, I think. I mean, shifting, I don't know if we have any method then. Because then we can use arrays, fixed arrays.
Okay, let's just do the vector queue for now. We go to the depth later.
Okay, so we do vector queue And
yeah,
then
and also in apply there will be a bunch of errors now.
In apply here, why here is complaining? I'm not following this one. So here we are going into the hallway. We didn't change the hallway.
Yeah, but it's not remove anymore. See that now remove is giving an option. It's pop front now, but now we have to unwrap.
Oh, right. So now it's pop front. And
Yeah, without the
and
zero,
we don't need a 0.
And we have to unwrap because now it's returning an option.
Mm-hmm.
Now I think everything downhill is fine. And then there is also in the out command, this is the out, in the in command, we are doing something too. That is when we insert in 0, so line 114, we have to do a push front. That is a push front of the amphipod. Okay. Now, in our solution, where we do the state equal vector.
In our solution, state
part
equal
1.
Part 1, okay.
We do line 13.
Mm-hmm.
Do the queue of borrow.
Okay. And this is a vec. Now states instead of being pop is
pop back and push back in where do we push?
At the
Scroll.
end.
Yeah, and push it back. Now, in theory, this must still work, and let's hope in less than 22 seconds. But I also would like to see this running in a release mode just to have an idea.
The easiest thing is that we can run the benchmark. Currently disable part 2, or even if we run part 2, I mean, part 2 will be super fast because we already returned the hard-coded solution.
I was expecting this to be a little bit fast. Seems not.
Still quite slow.
Yeah, but it's very small vectors.
Mm-hmm. Even slower.
Nice. Okay, let's go back to vectors.
No, wait. Let's try it in debug mode. In bench.
Nice. Good optimization, Luciano. Those are the good optimization. Now, okay, let's do that stuff with the constant in the type. How is it called?
Const generics.
Const generics. My God, I will never remember. The const in the type. When I say the const in the type is the constant generic.
Exactly, yeah. Because it's a constant, but it's generic. It's constant when you define it.
When you compile.
Okay. Oh yeah, because it's recompiling everything in release mode, basically.
Yeah. Okay, this will take a lot. I'm only doing 100 iteration. Okay. I think we can go back to the code, start writing the const generic while this is running.
Sounds good.
Yeah, so keep it there so we keep an eye on it.
That should look something like const
depth.
What do we call it?
Depth. So you remove line 4. At this point, you remove line 4.
Line 4, yeah, which will start to complain a lot. And this guy here.
No, everything is that can become an array. Next optimization.
Exactly.
Do that later. I want to see part 1 and part 2 with OKs. We commit and then we make it an array.
No, wait, because depth like this is not something you can read.
No, you can't do that minus something. I think you can.
You can use it only to sides. So we can use it here to say, for instance, option.
I think we used that somewhere. I think we used that somewhere else in math. Go back to before. Let's try. Go back to before. Go revert to the vector, to the DQ.
Where do you want to see it? Let me understand.
Revert this line.
Okay.
Now scroll to where we use depth. Aside that in implementation we need
right?
Yeah, go in the implementation of this block. The first line of this block is an impl. We have to say the const generic in the
all this stuff needs to be const generic. Oh, I see what you mean. Yes, yeah. So we need to say the
yeah.
Something like this. Is it? Or we need to say const the sides. But let's just call it depth at this point.
Right. The function must not be annotated, or they must be annotated, the function.
Okay,
No,
I think at this point you can use depth. Yeah, that's correct.
Yeah, at this point you can use depth. We already did this before. Yeah.
But
So
this is not saving you anything. You're just moving the constant from a global constant to a constant declared when you
but
create.
now we can solve part 2.
We can solve part 2. Yeah, we need to do a few changes as well. Because when we
have to add the lines.
When we instantiate, we need to specify we are instantiating a thing with cost 2 or a thing with cost 4.
Yeah. And for part 2, we have to align the fake to add the fake lines.
Is this still running? It is still running.
Yeah.
Oh my god.
Let's go on. We'll keep
So in lib, for instance, here now we should complain, right? Or not? When we parse. This is
why
interesting.
is not complaining?
I have no idea. Oh no, this is going in the place where it shouldn't go. Okay, I think it's complaining. Oh yeah, it will complain below, because when we implement the from string. Yeah, now I don't know if we can do this anymore.
You can do a from string on typed.
Let's see if we can do it in a generic way. So we can do const depth usides of this. And now, okay, that's fine, because I think at this point it's inferring. Is it inferring?
I seems so. I don't see any error.
Okay, I was expecting that here we needed to say depth.
But... me too, but it seems not. Is happier without, so.
Or is it like this? Why there is still one error? What are we missing? Generics, where? Oh, this is the test, okay. In the test, we need to say 2.
I think you're missing, yeah.
Okay, then where else? In part 1, we need to do the same. And here, yeah, as well. This is super annoying.
There is a way to do an alias of like type borrow 2 as borrow with the turbo fish.
Maybe there is. Turbo fish. Also, why here we don't need the 2 columns? You can just do this.
But it's fine. I mean, I saw other languages doing that, so I can relate.
Okay. So here it's finished, and it's taking 3 seconds. 3.2 seconds.
Python is taking 7, so it's faster than Python. Now, we can copy and paste this for part 2, adding the lines and creating a borrow 4. But the logic is the same, so we can make a function that is in common.
Yeah, let's do fn solve. And
it takes
what do we want to pass?
It takes a borrow
of any side. So let's make it generic.
Size.
So fn, how do you do a function generic like this, I think? Const depth 2 sides, solve, and it receives a reference to a borrow
depth.
So let's call it borrow. Right, and it returns a usides.
Yeah.
Now, is this the right syntax? Let's return 0 for a second. Oh, that's not the right syntax. So does this guy go after the name? I can never remember. Yes, it does. Cool. So we can copy all of this.
I never remember that. No, not the first line, not the parse.
You are super right. So we need all of this. We replace it here. And
theory, everything must be fine. Why the queue is not happy anymore? Because it's not. Don't pass a reference. Pass the borrow, because we don't care about keeping it.
Oh, you're right. Yeah, we can just still. Why is it complaining?
No?
What is the problem? Mismatch types. Expected. Why is expected? Oh yeah. Because.
We have to write the depth everywhere. Yeah. We have to write the depth everywhere there is a 2. Yeah,
that's good. And now we can return solve of borrow.
Yeah. Now part part2 is the same, except that we have to alter the string
so we need to
for
do
the parse.
let new input equal. How do we do a string concatenation? Let's see.
We have to concatenate it between two lines, so we have to split the lines and concatenate in the between.
Okay, so let's do let first line. Actually, let lines input the lines, and let first line.
We have to keep the first 3 lines, then adding 2, and then adding the last 2.
Yeah, let last line. Oh wait, we need to keep the. Let me see the input again.
We needed to take the first 3 rows.
1, 2, 3.
Adding the 2 fake one and adding the 2 that we have left. So 3, 2, and we have to add 2 in the middle.
So, how do we do that? Let's do lines equal to back of str. Lines.collect. And now we have all of them basically there.
Yeah, now we do lines.insert in position 3.
Yes.
Of the fake line that is space sharp D C D sharp C sharp B sharp A sharp.
And there are other 2 spaces at the end, right?
Yeah, those are optional.
Which doesn't really matter because
no, they don't really matter.
They don't even exist here, so I'm not gonna even bother. Why
and
are you trying to join? Calm down.
Now we have to insert in.
Oh yeah, and this is double quotes. Sorry, because otherwise that means
JavaScript.
But that means it's a char, so you cannot do it here. Okay,
now
why this needs to be mutable? Wait.
Yeah, and now, not assigned to a new input. Just modify a line.
Good point.
Now insert in position 4. The sequence of letter is D B A C. D B A C.
Okay.
Now we have to parse it. Let borrow.
It's equal to lines join /n, right? Yeah. And then as str. And now we can do let borrow equal input dot parse. Well, not input, new input.
New input, yeah.
Look at that. Even the for. It's guessing even the for.
Nice. And then we have to solve burrow.
Okay, almost there. Why is it complaining? Join. Temporary value dropped. Oh, okay, because to do as string, you need to store this. Okay, we don't need to worry. We can just do this and then
as ref,
as string here.
Yeah.
To be fair, does parse work even directly on string? I'm just curious. Cool, it works even on a string. So they do the as str internal.
So part 1 is working. Let's see. Was working. We have to test again.
Do you want to run part 1 first? Or let's run both. Let's see what happens.
Let's run everything.
It's going to take a bit, but yeah.
Oh, it's going to take the 33 seconds from before for part 1. In theory, part 2 is faster because of inputs. You have more constraint. Part 2 seems fine because it already said okay. Also said okay for test apply.
Part 2 was super fast. Okay, good.
Part 2 is faster because with more letters you have less possible moves in the end. Because they always get very filled immediately, so you don't have a lot of moves. With part 1, with less letters, you have more.
Nice. So, okay, let's run the benchmark.
Do a commit.
Yeah,
then
let's
we
do a commit.
Which refactor do you want to start with? The array instead of the vector, or the
priority queue?
Priority queue. Probably the array is better to start with. Probably
should
the one
be
giving us more speed.
Easier. Should we do a cargo bench first?
No, it's taking forever, remember.
Well, while we try to do that.
Oh yeah, while we go with a cargo bench.
Okay, so the idea is that if we...
Yeah, instead of that alls the queue, instead of being a queue, is an array of some amphipod of length depth.
That's the idea.
Yeah.
Now, what is this going to buy us? It's going to buy us that we keep things in the stack rather than allocating all the time, right?
Yes. But we have to implement the len ourselves because the len will be the number of the number of some element in the array.
That's true.
And when we push in and take out, we have to go to the first location that contains a known, because we don't want to overwrite, and we have to keep a track of the of how many amphipod are in the hole. We want to keep an additional variable with the number of amphipod in the hole.
I'm wondering if it's worth doing something like this. Yeah.
add usize that tell us how many amphipod are in this hole.
But that's a dynamic thing.
Yes, for this reason.
Like an implement, like a dynamic function.
No. A usize.
And we need to update it every time we write into this.
Yeah, we have to implement add and remove from the hole.
Okay, then it's fair. Yeah, I like it. So we can do
size. Easy is the size. Easy.
Yep.
Size usize.
And then what we want to do is implement on hole. Well, we need to do the
size for the hole that is of depth.
Hole depth.
Have you done a commit before starting all of this?
I did.
Okay, sorry.
So what do we call it? Push and pop, or not? Because we need to know.
No, we always push in the front and pop from the front. Push and pop.
Is that going to be enough? Push
and len. We also need len, but
we need len.
Len is the size, so we can if maybe make size public.
Okay, later, but for pushing and popping, we don't need the len.
No, we need the len to know where to put the stuff. Size is 0 at the start. We push and we put in the array and index 0, and we increment size. The next time we add, we will put in 1 and we increment the size. When it's 4, it's going to explode.
But it's part of our internal state. It's not part of the input, right?
No, it's part of the internal state. Yes, exactly like that. The new we have. Let's implement also new. That is filling amphipod with nulls, or is that okay with known? Exactly, perfect, beautiful. Thank you, Copilot. And the pop. Let's see if Autopilot is making the magic.
If it's 0, returns none.
Yeah, correct. Otherwise, go back 1, return, and take. Take, what is take doing?
No idea. Takes the value out of the option, leaving a none in its place.
Beautiful. It's what we want.
Exactly. I didn't know this one. We are learning from Copilot. We are not just teaching Copilot. We are also learning.
I was about to put that in a variable, then set that location to known and return the variables. But if take is doing that, cool. Now, let's use this.
Now here we need to replace this vector queue with
an hole of depth. Now it's complaining because
we need to implement all the thingy. We need to derive bug clone. We don't want copy, I believe. Everything else, yes.
Let's try to remove it and see if somebody will complain.
Okay, now it's happy.
Okay. Now we have to go in the shit.
Do we want an is empty? Should be easy to do, right?
Size equals 0. Yeah, let's implement the is empty then.
I'm gonna start to move it into another file.
I know.
That's size equals 0. Beautiful. Now iter, it's we could do something smart to make that work. We could reference to amphipods.
Yeah, but he's also giving back the known. We just want the one that have a sum. Can we implement the iter? So can we implement something that is?
Yes. Let's move it to another file because otherwise it's a mess. Okay, so here what we want to do is mod hole, which is basically like saying copy the content of the other file inside here. Is that it?
In the meantime, part 1 had a benchmark of 3.1, that is, and part 2 a benchmark of 700 milliseconds.
I'm gonna do it here.
So the cargo bench is done now down there.
And these all needs to be pub crate. And it needs to import this guy. Yeah, and this guy needs to import the other one. Okay, so I don't know if that's worth recapping, but basically when you want to split things into multiple files, there are different ways of doing it. I generally like to keep them at the top. So when you do mod, it's like you are flattening everything in the main, like literally telling the compiler copy paste the code here. But because they live in their own file, it's like they have their own namespace, which is called as the name of the file. So you also need to import them. Like here we're doing use borrow with. So this way we are actually allowing the rest of the file to see that.
If you do that, but you don't do the pub create mod, it's not finding it?
So here, actually, I don't think it even matters, maybe except for tests. In the other one, you need to use pub create. Here, I'm not too sure. Oh, yeah, here you need to do it if you want to allow other modules to see them, which, for instance, we want a borrow to see an amphipod and to see whole. So that's why we need to re-export it publicly.
Okay.
So here, what we want to implement is the iterator, right?
That gives back only the...
Okay, meanwhile here is finish, and this is actually slightly faster, and this one, of course, is super slower because before it was not doing anything.
Yeah, but that now is doing a real job and is 700 milliseconds. If we do this type for the array and we run it again, we can see some difference in the times.
Okay, so implement iterator. Iterator, let me think. Or we need to do into iter.
Long story short, we have an array of some unknown. I want out something with only the one that are some. Can be a vector of amphipod, can be an iterator of amphipod.
For all depth. Isn't it this what we want?
Do you need to materialize the amphipod? Is not an iter enough?
Wait. Expected trait found struct. What's the name of the into iter? Maybe I don't remember it correctly. Oh, it's into iterator. Okay. Now, why doesn't like it? This is what I was expecting. We could have added here more stuff, I think. Tell me just the error. What is the error? Not just the error in this file.
You must implement iter.
Oh, okay. Mistype into iter. Which kind of iterator are we returning? Is that the kind of iterator are we returning?
We are returning amphipods. Yes.
What are the different arguments? T and cost n usides. Wait.
All of this to do the iter down there?
I think so.
Can we change the code down there if we want? It's not a problem. It's our code.
I'm not too sure why we need to return two of them. No, this is not what we want. I think this needs to be the type of iterator. So it's an iterator where item equal option of this. Actually, we can just say this is literally what we want.
Yeah, we want amphipod out of that. But why is
it needs to include... Okay, let me see if there is an example here. My collection, how do they implement it? Standard vec into iter. Self item.
Well, we have self item. I guess.
What does this one return?
Do a let so you can see. Assign that to a variable so you have the type inferred. What is the type of M?
Into either ambivot and depth.
He has to keep the depth because it's a const. I write that. Option amphipod. Because you don't want
now
to. The type returned by into iter is correct.
What if we just say this?
If you remove that, what's happening? Is inferring the return type or not?
It's inferring the return type. I don't think it can infer a return type in a function.
Well, but we are inside a trait.
So what is it saying here? Self into either. So that's okay. That makes sense. So we need here to always return whatever we say here is the return type. So the return type is generic, and we need to define it with associated types. So self into either. Why do we need to specify? I thought we just need to specify the type of an iterator. That's why I'm getting confused. By implementing into iterator for a type, you define how it will be converted to an iterator. This is common for types, which just describes a collection of some kind. One benefit of implementing into either is that your type will work with Rust for loop syntax.
Okay, now if we do self amphipod into iter, it's going to work or complain?
That's what we are doing here. It's still complaining. Expected a struct of std option amphipod amphipod. Instead, it found std array.
Because the iterator must terminate, so we must return an
okay,
option
because
of the
here,
amphipod.
This is what we said here. That's why it's complaining. Now here, this needs to be an option as well.
Like, can't you say item there? No.
Can't you say where?
Item. Instead of option amphipod, you write item. Define the line above. Yeah.
Yeah, okay. Which is not what we want. If we only want to keep the ones that are not optional. Is that correct?
No, we want to keep the ones that are not known. We have some known in the array.
Yeah, exactly.
We have to return optional, known, last to terminate the loop. So we have to filter by
filter. So x
is not known. Not x is known. Is a sum. X is sum.
Now this is not going to like it anymore because now we don't have the option, right?
You were too fast. I was not able to read.
Okay, now it's a filter, and that's not a big deal because now we can just say either filter.
We have to materialize the filter. How do you materialize the filter? Dot collect?
No, we don't need to materialize. I think we just need to change this type to be what was before. Is that gonna be enough?
You need some more close.
We need takes two generic arguments.
Do comma depth before the last closed angular. No, before the last closed. No. Leave the depth there, but also add it. Comma depth closed angular. No.
Type was expected. So filter, what does he want? Filter. Oh, filter wants item.
What is P? I is the item.
And P is the predicate? Oh my god.
No, but here we are implementing the filter itself. Go back to oh my.
And filter, does it implement into either?
Just to go back to our problem is to look if all the amphipod in a hole are the same. That was our problem.
Okay, you know what? Let's not bother with traits. We can just do fn.
All are all.
Either. Right? Either field. And this one takes a self. And it returns an implement iterator. And this returns amphipod dot iter dot filter.
No, he was right. He was right. Because we know many are there. Just the first one will be filled.
Okay.
Now he's complaining about what? Lifetimes.
Not appear in bounds. Cool. What if we just do this? Why does it need a lifetime? This trait takes 0 lifetime arguments. So what do you want from my life? Oh, I have no idea what this means.
Me neither.
I think it might mean that the items produced by this iterator have a lifetime that is the same as this struct, but it's a wild guess.
Okay, let's try to fix the rest of the code so we can see it running before going to dinner.
Okay, so is empty. We did have is empty, right?
Yeah, it's public.
No, that's why.
Everything needs to be public, I think. Otherwise, we are not doing a lot. Okay, better.
Now, iter field, we call it, right?
Yeah. And is giving what I was expecting about an amphipod there, to be honest.
Oh, but here we still get options. We need to map if we want an amphipod. We need to map and wrap.
Oh, or on the other side, we can unwrap on the other part of the code. No.
Okay, let me try something super quick. If we do filter map, so what we want, but either. Okay.
Okay, at this point, we are not returning an iterator or yes. What are we returning?
We are still, filter map doesn't materialize anything. It's just
okay.
creating a dynamic iterator. Okay, now it likes that. Now
okay.
what's
what
next?
else we need to change?
Yeah.
The parser, probably. We are doing... what is that?
Desired OM. What was desired OM? Oh, yeah, it's the all we selected where the amphipod wants to go, basically.
Mm-hmm.
So this, again, needs to be either field. But we can actually use here the helper, right? Can we just say is full or something?
No, that is the part that say all the amphipod already in the hole are of your type.
Mm.
If the hole is empty or is filled of your comrades, the teammates, same animal, go in. So it's fine, it's correct. The only stuff is that we have a reference and a real amphipod that equal on line 8. Yeah, so yeah, I think it's enough. Okay. And another place that we need to fix is for sure
here.
Yes.
Length. We don't have a length.
We have size directly. We have size directly.
But we can just do for simplicity for
pub create function length return size of self. No, a reference to self. You forgot the reference to self.
And I forgot also the type.
Okay.
At this point, nothing needs to be public there. Okay, now we have push front, which becomes push and pop.
Yeah, we call it then push and pop. Okay.
Yeah. And now holes is different because we can just call new, right?
Yes, there we have to think, because we are pushing in the back when we parse, not in the front.
Wait, but let's initialize the thing first.
Yeah.
Holes for new.
Yeah, but
now
we need
this
for
needs
an
to be
array of 4.
imported.
That must be an array of 4, also 4.
Oh, yeah.
That is our array of 4, also of not 4, but also of depth. Also of depth. Depth. Not 4, depth. No.
Oh, wait,
we always have
wait,
we always have 4 holes, even if they are of depth too.
Now, please import this guy.
Try to remove the 2 semicolon.
Sorry. And now give me that. For depth maybe goes into.
That is the depth of the hole. That is a const generic of the hole, right?
I think so. So does it go here? Where does it go?
I say that the copy is not implemented because you are trying to clone it 4 times.
Right. Okay. So that was the same problem we had before, and that's why we repeated it 4 times.
We repeated that 4 times because we are lazy. Yeah.
And now push becomes, is it pushback? No.
No, we don't have that function. Now we have to think. Here we were taking the parsing of the file. We were pushing on the back because we were rotating everything. Are we rotating here, or are we doing something different? No, we are not rotating here. So here we go by position. We go by char.
Can we implement like a pushback ourselves where we shift?
I'm trying to think if we can come out with something here. No, because we have to add after, or we go through the lines backward. Do this. Use a push. We can do this. Use a push. Let's try. Use a push. Now, in line 158.
158, yeah.
158. Go to S lines reverse.
Ooh, can we do that?
Dot skip 1. S lines reverse. Can we reverse that? Can we reverse the lines?
We can skip one.
Yeah. And now in line 161, you have to break if you find a dot. That is the whole way. If you find the whole way, you're done. This way, we are filling instead of from this way, this other way, and then we just need push.
Okay, so we still have a few errors. Probably in the test. Oh no, ether is ether field. And this is without the reference. Okay. Good.
Any else? We have warnings.
We have this warning, which we didn't end up using anymore. Here we have another warning. This vector Q, which we don't use anymore. No more warnings. Should we run the test?
Perfect. Run the test. Part 2 is fine. Part 1 still slow as crazy. We can run. We can run cargo bench. It's taking forever, but we can. Oh well, it's faster. It was 33 seconds.
Yeah, I think it's a little bit faster.
With the vector was 23 seconds. Now it's 21. So between vector and array, there is not this huge difference, but still working. Other optimization, but we are already at, I think, 2 hours of streaming. So
yeah, I will probably call it a day, and we can try to think about optimization offline and maybe show a PR next time if we have time, or if people wants to try optimize, definitely send us a PR.
I think what stuff is worth to try is the priority queue for the states. So instead of using a vec the queue, right, like now, using a priority queue, using the score as a key, as the minimum, or the key for the minimum, if you want to commit everything and run a cargo bench. And other optimizations, in theory you could what? try to use the moves that cost less before the moves that cost more. Now, when we give moves back, we give all the possible moves, but we don't. We give them out of how they are. I mean, we don't look at the amphipod. We can give the amphipod A before the B, before the C, before the D. So there we can sort the moves, because we return a vector, I think, for the moves. We can sort it by cost of the move. So I give you first the move that are cheap, and then I give you the moves that are more expensive.
Yeah, we will need to check if sorting ends up being more expensive than actually trying that solution.
Yeah, obviously. Okay, so let's wrap it up. The recording will be on YouTube. The link is on the Twitch in the About section. If you're watching this on YouTube, we do live streaming on Twitch every Monday, 5:30, 6 p.m. Dublin time. Make sure to check the Twitch link in the YouTube description. Give us a follow, ring the bell, everything else. Feel free to leave us PRs, open them. Everything is well accepted. We are trying to learn Rust. Don't expect our solution to be the best ones, but they are working typically. If anybody knows a better way of doing stuff, please tell us. Are we going to rate somebody?
Yes, we are going to rate Togglebit, who is always doing interesting Rust projects. So hopefully you're going to enjoy some serious Rust, not like our noobs Rust. So have fun. See you next time.
See you. Bye.